Let's be honest. The word chemistry can sound a little intimidating, right? We kind of picture these crazy labs, maybe some baffling equations on a chalkboard. But what if I told you that chemistry is actually the secret story of, well, everything? I'm talking about your morning coffee, the food you eat, the phone in your hand. So in this explainer, we're going to pull back the curtain and show you the hidden worlds of chemistry that are all around us every single day.
Okay, so let's just dive right in with the big question. The one you'd ask on the first day of any class. Why are we even here? Why should we study chemistry? Is this whole thing just about, passing a test or something?
Well, here's the surprising answer. Turns out you're already a chemist. Seriously. Whether you realize it or not, you're basically running chemical experiments from the moment you wake up.
Think about it. That first cup of coffee you made this morning, that's actually a chemical extraction. You used hot water, which is a solvent, right, to pull out all these specific compounds from the ground beans. And I'm talking about the stuff that gives it that incredible smell, that amazing flavor, and of course that caffeine kick we all need. That's literally pure chemistry in action, right in your kitchen.
Or what about hopping in the shower? The way soap and shampoo work, totally chemistry. They're made of these really clever molecules that have one end that loves water and another end that loves oil. So what do? They grab onto all the dirt and grime and let the water just wash it all away. It's such a simple, elegant chemical solution to a super common problem, right?
And come on, what's the first thing most of us do in the morning? We check our phones. Well, that phone, the lithium-ion battery that powers it, the liquid crystal display you're looking at, the silicone and the microchips, all of it, every single part, is a product of decades of advanced chemistry. You are literally holding a chemical marvel in your hand every single day.
This drive to change stuff around us, to manipulate the world, it's not new at all. In fact, you could say it's an ancient human quest. For as long as we've been around, we've been trying to transform matter into things that are more useful, more powerful, or even just more beautiful.
Just look at this journey we've been on. It starts way back in the Stone Age, with something as simple as changing the shape of matter, chipping flint into tools. But then comes this huge leap forward, using fire to change the actual composition of matter. Think about turning clay into pottery or ore into metal. It's a game changer. From there, you've got the ancient Greeks trying to explain it all with their 4 elements, and then the alchemists, chasing that dream of turning lead into gold. Every single step, whether it worked or not, was a totally crucial part of the path to what we now call modern chemistry.
And this long, ancient quest, it has had absolutely life-saving consequences. See, modern chemistry doesn't just help us understand the world, it gives us the power to change it for the better. And that brings me to the incredible story of one particular chemist I want to tell you about.
This is Percy Lavon Julian. Now, back in the 1940s, there were these powerful, life-saving medicines like cortisone, but there was a huge problem. They were so rare and so expensive that pretty much only the very wealthy could afford them. But Julian, this brilliant chemist, he found the solution in the most unlikely place you can imagine, the common soybean. He figured out a way to create the key parts of these drugs from soy, which was cheap and plentiful. And just like that, he made these critical medicines affordable and available to everyone. It is absolutely not an exaggeration to say that he laid the groundwork for modern drug design and made life-saving treatments accessible to millions and millions of people.
So how did he do it? How do chemists actually get from a simple soybean to a complex, life-saving drug? It's not magic, not at all. It's a systematic process. It's like a powerful toolkit for asking questions and finding answers. And that toolkit has a name: the scientific method.
And it's really important to think of this as more of a path for discovery, not some rigid, boring checklist you have to follow. It all starts with an observation, just noticing something about the world and asking, why is that? That curiosity leads to a hypothesis, which is really just an educated, testable guess. Then comes the fun part, the experiment, where you actually go out and gather data to see if your guess holds up. And based on those results, you start to refine your ideas into a solid theory or maybe a scientific law. It's this constant, awesome cycle of curiosity, testing, and discovery.
Okay, and getting these terms right is so important, because in everyday language, we throw around the word theory to mean just a hunch or a guess, right? But in science, it's basically the opposite. A hypothesis, that's your initial guess. A scientific law describes what happens. For example, the law of gravity tells us an apple will fall from a tree. It doesn't tell us why. The theory, now that's the grand prize. It's the well-tested, evidence-backed explanation for why it happens. It's the theory of general relativity that explains gravity itself. So a theory is the pinnacle, not the starting point.
All right, so we've got the history, we've got the scientific method. Now we're going to get to the core idea of this whole explainer. And I promise you, this is going to change how you see the physical world around you. Chemists learn to look at any substance, I'm talking a drop of water, the plastic in your chair, anything, through 3 different but totally connected lenses. They call them domains. And to make this super clear, let's use one of the most familiar things on the planet, plain old water.
First up is the macroscopic domain. Macro just means large. This is the world we experience with our senses, the stuff we can see and touch and measure. So when you look at a giant iceberg, or you feel rain on your skin, or you watch steam rising from a pot, you're observing water in the macroscopic world. It's the big picture, tangible world we all know. Okay, next we're going to zoom way into the microscopic domain. Micro means small, obviously. This is the world of atoms and molecules, a world so incredibly tiny that we mostly have to visit it in our imagination. So in this world, we can actually picture water as trillions and trillions of little H2O molecules. And this view helps us understand why ice is solid. It's because those little molecules are locked tightly in place. And why steam is a gas? Because they're flying all over the place, far apart from each other. And finally, we have the symbolic domain. You can think of this as the special language or the shorthand that chemists use to connect the other 2 worlds. The chemical formula H2O is the perfect example, right? That one little symbol represents a single tiny molecule in the microscopic world, and it can represent a vast ocean in the macroscopic world. It's the essential code that lets us talk about it all.
So what's the point of all this? What's the big takeaway here? It's that once you start thinking in these 3 domains, you really do start to see the world in a completely new, much richer way.
Let's bring it right back to where we started. Think about your morning coffee again. You see the dark, hot liquid? That's the macro world. But now you can also imagine all those little caffeine molecules zipping around inside it, getting ready to work their magic on your brain. That's the micro world. And you know that the whole thing can be represented by chemical formulas? That's the symbolic world. Your soap, your phone, everything suddenly has these hidden layers. You're starting to see the world like a chemist does.
And that brings us to our final thought. Now that you know how to look for these hidden chemical worlds, now that you have the lenses to see them, the real question is, what else are you missing? What else is out there, hiding in plain sight?